Hi, welcome to the Large Lakes Observatory, often called the LLO. We're here in the Biological Limnology Lab, and my name is Tesha Coker. I'm a grad student in the WRS program here in UMD, and I'm looking at sediment, storms, and algal blooms in Lake Superior.
My name is Isaac Conrad. I'm a second-year student here at UMD. I'm a double major in biology and communications, and I'm an undergraduate research assistant at Dr. Bob's lab. Here at the LLO, we study the Great Lakes, inland lakes, and rivers. We study water chemistry, sediment chemistry, and the biology and chemistry of the organisms that live within. So we study phytoplankton, zooplankton, mussels, snails, and fish, anything in between.
With climate change, we're seeing more storms and more intense storms. These storms are transporting sediment out into Lake Superior, occasionally resulting in an algal bloom. With my research work, we're able to study the relationship between that storm-derived sediment and algal blooms. The frequency of algal blooms are increasing in the Great Lakes and have the potential of toxicity, which can be harmful to visitors of the lakes, such as pets and people.
During the summer, we collect all different types of sediment samples. We collect these sediment samples from the Lake Superior watershed, and we test these samples for phosphorus. We measure them for phosphorus because phosphorus is an important limiting factor in algal growth.
I measure phosphorus in riverbanks and lake sediments, and I do this with the use of resin strips. Now, resin strips are a way to extract phosphorus from sediments. We take a pair of them, a positive one, cation, and a negative one, an anion, and we put them together in liquid with a small bit of sediment. So we take the small amount of sediment, add some liquid and the resin strips, and then we load them up into the hedgie huts. We call them hedgie huts because I have a hedgehog and he would love to, sit in there. We put them on this roller and we turn it on, and then we allow the extraction process to go on for about 16 plus hours. This is very important because it's allowing the resin strips to come in full contact with the sediment that they've been placed in. So after the extraction process is done, we would take the resin strips out from the tubes and grab the solution, and then we'd use it on the AQ400 using the analyte phosphorus.
There's lots of different ways to look at the chemistry of water, plants, animals, and sediment. One of the most common methods we use is called spectrophotometry. That's the addition of chemicals or mixtures of chemicals called reagents to produce a color with the intensity proportional to the concentration of the element or chemical being analyzed for. One of the most important principles of spectrophotometry is Beer's law.
In Beer's law, we're looking at the concentration within the solution. And the higher the concentration, the less light will be able to pass through it, as we can see in these diagrams. So before we had the current technology today that allowed us to analyze it, they had to use a known range and then compare an unknown to see what the concentration was within the solution. As you can imagine, this was very time-consuming and difficult. So advances were made in technology so that we wouldn't have to do this manually every single time we wanted to analyze a sample.
One advancement in spectrophotometry is the dual beam UV-Vis spectrophotometer. The dual beam spec lamp produces light which is focused and split, so only a specific wavelength of light is beamed through a sample. One beam is sent through plain water, otherwise known as a blank, while the other beam is sent through the sample. The difference in the amount of light detected on the far end is the amount of light absorbed by the sample. So the darker the color of the sample, the higher amount of light absorbed, and the higher amount of light absorbed, the higher the concentration of the measured chemical.
This is still a time-consuming process, but it's a lot more accurate than trying to compare it by hand.
At the LLO, the way we perform spectrophotometry is using the SEAL AQ400. This is a fully automated analyzer. So we pour up water or a prepared plant, zooplankton, or sediment sample. We fill different wedges with reagents, and we select a program to run.
We measure different kinds of analytes using the AQ400. So anything from phosphorus, silica, to nitrates, and there are about 30 different analytes that we can analyze and measure using this machine. So this is the SEAL Analytical AQ400. Some advantages of using the AQ400 include that it is time efficient, You need very small amount of sample, and we can measure for many different analytes at the same time.
Spectrophotometers help us to better understand algal blooms, which in turn aids policy in the goal to improve water quality. Lab experiments written up in research and publications increase literature on the topic of algal blooms worldwide.
Once again, my name is Tasha Coker.
And my name is Isaac Conrad. Both Teso and I are very grateful for the opportunities and the resources provided by the LLO to further our academic careers.
Thank you for listening and have a great day.